All right, everybody, this is 6.2. Just to let you know that it will be kind of a lengthy lesson. So I'm going to break this up into a couple of videos. Okay, so we're doing radian measure. So again, radian is just it's a different unit. So we're going from, in 6.1, we learned how to convert from degrees into radians. Okay, what you do is multiply by pi over 180. Okay, but now we're going to apply that to now angles on the Cartesian plane. Okay, so recall from grade 10 and 11 that we have sine, cos, and tan. So we have SOHCAHTOA, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is O over A, or opposite over adjacent. Okay, so if we're looking, if this is the angle here, or what I usually label first is the hypotenuse because it's the easiest one to recognize. And it always stays in the same spot. This is 90-degree angle. So we have our hypotenuse, which is across from the 90-degree angles. And then depending on where your theta is, or your angle, will determine whether your opposite and adjacent are. So if we're looking at this angle here in the bottom right, then our opposite side is across from it, so that becomes the opposite. And then our last side is the adjacent. Likewise, if we were to look at, say, this angle here, say we call this beta, then if we're using this angle, then across from it would then be the opposite side. So this would be opposite if we're using this angle, and then this would be the adjacent side. Okay, so now we have the reciprocals functions. So we have cosecant, secant, and cotangent. Okay, and I don't remember if you guys did this in grade 11. I think you have. Okay, so cosecant is just the opposite of sine, so you flip the hypotenuse in the opposite. Secant, opposite of cosine, and then we have cotangent, which is the opposite of tangent. Okay, so let's do a couple diagrams here. Okay, so let xy be a point on a terminal terminal arm of an angle in standard position, and the side opposite is y. Okay, so let's draw this out. So if I had a Cartesian plane, okay, so I just put the arm out this way. Okay, so if I take a point, this would be point xy. Okay, so this is the terminal arm. Terminal meaning the end. So this is our second arm, or end arm. Okay, in standard position. So we have an angle here. Okay, so what we could do is we could draw a triangle, okay, which would create a 90-degree angle. So we have a right triangle. So the side opposite of the angle is your y. So that's what it says here. The opposite of theta is y. Okay. The side adjacent to theta is x, which makes sense because this is our x-axis. This would be our y-axis. And the hypotenuse is now r, okay, which is our radius. Okay, so we could always find r by using the Pythagorean theorem. So one thing I also want to add is this arm here that goes along the axis is called our initial arm. An initial arm. Okay, so we have theta, we have our opposite, which is y, our adjacent, which is x, and then our hypotenuse is now r, represent the radius. So with that, we now have different things that we can put for our trig ratios. So sine theta is now y over r. Cos theta is now x over r. And tan theta is now y over x. Okay, so we're kind of eliminating the O and the A and the H, and we're using x, y, and r. Okay, but I always go back to opposite, adjacent, and hypotenuse. Okay, so then if we have the reciprocals, so the cosecant would be r over y. Secant would be r over x, and cotangent would be x over y. Okay, so those are the new trig ratios. So these are the original ones you guys learned last year, 2 years ago. And this is our new ratios using x, y, and r. Oh, I just wrote, they're right here. Oops, I just realized I wrote these, they're at the bottom here. Okay, so they're all written out there. Okay, so we also have to recall the special triangles. Okay, we're going to be using these quite a bit in this unit. Oh wait, I want to do something else. Let's look on the next one. Oh, yeah, it's on the next one. Just want to put something else here. If we had an angle, so if say we had a angle going this way, so this is still your theta, okay, or your principal angle. So principal angle. This here is still your initial arm. The second arm is still your terminal arm. But now our triangle is in this quadrant. Okay, so this, I just forgot the name. The principal angle is on the outside of the triangle now. So now we have an inner angle, which is called beta. And beta is your related acute angle. Pretty sure you guys do these in grade 11. So principal angle, related acute angle. And then obviously we have your y, x, and r. Okay, so special triangles now. So you guys touched on these in grade 11, so we're going to use them again. So 1 and 2. I'll make this one a little bit better. Okay, so this is how I remember them. Because, we're going to have them in front of you, but that's how I remember it. 1, 1, 2. So 1 plus 1 is 2, and 1 plus 2 is 3. So these numbers are going to be for the special triangles. Okay, so the special triangles, so I'm just going to recall. So 60 degrees, 30 degrees, and they're 90. And then we have our 45 degrees on each here, and they're 90. Okay, so 30, 60, 90, 45, 45, 90. Okay, so the side 1, 1, 2 would have to be on an isosceles triangle. So the isosceles triangle is the 45 degrees. So the two sides that are the same are here and here, and that means the 2 will go on the hypotenuse. Okay, but we're not finished with the numbers. So the highest number always has the square root. So it's 1, 1 root 2. Okay, and then this one over here, so this becomes 1, 1 root 2, and 1 plus 2 is 3, but it's root 3. Okay, so now we're going to plot the sides on the 30, 60, 90. So the smallest side would be across from the 30 degrees. So we look here, well, which one is the smallest number? And that would be 1. So across from the 30 is 1. Okay. Now, which one is the hypotenuse is the largest number? So which one is the largest here? Well, if you calculate root 3, that's actually lower or smaller than 2. So 2 is actually our largest number. And then our last one is root 3. Okay, so we have 1 plus 2 is 3. Put the square root on the largest number. Okay, and then we have 1, 1 root 2. Again, 1 plus 1 is 2. Put the square root in the 2. The ones are the same sides, okay, because of the isosceles, root 2 on the outside. Okay, but we are moving away from degrees, so let's go with the 45. So 45 is the same as pi over 4. Okay, so 180 divided by 4 is 45. So pi over 4 for both of these. Okay, so then we have, and remember 90 degrees is pi over 2, 30 degrees is pi over 6, and 60 degrees is pi over 3. Okay, so if you're not sure, just convert it. Remember, you multiply the degree by pi over 180 and then reduce. So pi over 6, pi over 3, and 45 degrees is pi over 4. Okay, so let's go through some here. Depending on which quadrant angle theta is in, the trig values will be used. Sides, which may be negative. The values of x and y could be negative, whereas r could never be. Okay, so when you're doing these angles here, so our x here, and we're in the second quadrant, so your x value is going to be negative here. That's what it's saying. Your y is positive here, so it'll be positive y, and your radius is always positive. Because when you do Pythagorean theorem, you're squaring this values. Or you're adding two squares together, which will be positive. Okay. Okay, so again, this should be negative. Okay, so recall these, the quadrants, 1, 2, 3, 4. So we start in the top right, and then we count counterclockwise. So quadrant 1, 2, 3, 4. Okay, then we also have something called the cast rule. Okay, I believe you guys learned this in grade 11 as well. So the cast rule, so we have C-A-S-T. Okay, so the A represents, in this quadrant, all angles are positive. Sorry, all trig ratios are positive. All ratios. That means sine, cos, and tan are positive in this quadrant. Okay, then we go counterclockwise. We have sine, S, which represents sine. So in this quadrant, only sine is positive. Okay, keep going. We go down to the third quadrant. So T. So in this one, it's tan. So only tan is positive in this quadrant. And lastly, we have the fourth quadrant, which is cos, meaning that cos, the trig ratio for cos, is positive in this quadrant. Okay, we're going to be looking at them. So all the ratios are positive, just sine, just tan, just cos. And also, so if sine is only positive here, that means tan and cos would be negative. Okay, if tan is positive here, sine and cos are negative. And likewise. Okay, I'm just going to stop this video because it's getting lengthy and start a new one.